This is our presentation on design technique, the REST, by Savannah, Dautel, and Kyle Josephson.
So what is REST? REST stands for Representational State Transfer. This is an architectural style that allows communication between computer systems and the web. A system is put into the REST category if that system is stateless and separates the concerns regarding the client and server relationship.
The reason communication between two computer systems is called REST is because of the architectural constraints placed on the way communication should happen. The constraints, when followed, makes it easy for one computer program to talk to another computer program. When the one computer needs information from another computer, the one requesting the information is the client. The computer providing the information is the resource provider. The resource provider has to follow these constraints to be considered a REST architectural protocol. I will briefly go over the list you see on the screen. The first requirement is that the resource provider must provide a resource. Kind of makes sense, but it does mean that many different types of computer programs can access this information. It is not just for one type of program. The information is a resource that anyone should be able to access. To make it easy to communicate, HTTP protocol is used. Any client that needs the resource must know how to access the resource. An example of this is like obtaining an API key for granted access or instructions on what information is available. File types used in resources must also be generally accepted file types, like MP3 or PDF. The resource must be stateless, layered, and cacheable. This is like almost any file system used in a modern computer. In other words, it must be easy to use.
There are many upsides to using REST. REST is considered easy to use due to it being well known by developers. It is a beneficial design tool to use because it is commonly successful at working well with different systems. It is capable of being modified. It allows sharing and merging of information from multiple sources, as well as providing stateless communication in a client-server focused relationship. There are a few downsides to using REST, two of which include performance and reliability. Because REST relies heavily on using other systems, it only works as well as the compatibility between the two. Another downside is that REST is usually used with a top-down hierarchical approach. So in order for there to be simultaneous agreement, REST has to be used asynchronously. REST is highly recommended for its client-server-based approach and because it allows stateless communication. This means that when a client sends a request to the server responds by sending back a response containing the requested data to the clients, and that the communication is handled as an independent event. REST is also recommended for its top-down performance approach, which means that tasks are performed from reading the code from the first event to the last. It also has the ability to be modified, and it allows the sharing and merging of information from multiple different sources because it works well with other systems. Because of these different factors, REST is beneficial and easy to use.
For the first part of our demonstration, we are going to show you this diagram. What you are looking at is called an API call overview. We are the client in this picture. We make a call out to our resource provider by using HTTP protocol. The resource has an API gateway. The gateway will do an authentication to make sure the client, which is us, has the right to do the needed information. The main way this authentication is done is through obtaining an API key from the resource provider. If authentication is good, then the gateway which accesses the service that is requested from the client. The gateway will then send back the requested information to the client in the response cache process. The gateway will also create a log for the resource provider so they know who is accessing what information, when, and how many times. This is an asynchronous event, so the call that is made does not wait for the response. When the gateway responds, then the program will continue with using the information. This is usually done through the client's listener function. For the Who Were You app, we're going to demonstrate how to use the API for Facebook, since that seems to be the most important and most used social app. Facebook requires the use of tokens. The token is like an API key, except that it is geared towards a specific user of Facebook. It grants the app the right to access the information needed. Except our app doesn't need access to information. Our app puts information on the user's Facebook account. For that, we need a special token called a page access token. This special token will allow us to publish to a page. This special token requires 2 permissions to gain this token. They are page read engagement permission and the page manage posts permissions. The client must also use a post request to publish information. The Facebook interface that uses tokens is called the Graph API. The instructions on how to use the Graph API are on developersfacebook.com. How to obtain tokens are also on this website. The example you see before you is from that website. It displays a post request to publish the message "awesome" to the page. When the message is published, the Graph API sends back an ID code to give confirmation of success. This is shown in the second example. That is our presentation on REST. Thank you for your time.